Hello, for data communications and network one class today, just I will talk about IPv4 address. As we have seen in the last clip, okay, the IPv4 address is still used more than IPv6 right now, okay, August 2024. Okay, so you still have to learn this. In the address field of the IPv4 address, we have 32 bits, okay, for source address and 32 bits for destination address. And the important thing that is that this is a global internet address, meaning of the global means that at any time, at one time, okay, only one user is using this IP address. So they can pinpoint you, okay, back to your device, okay, who is using the IP address right now, okay. So you have to be careful, okay. We also have the law about computer law, okay, but you should know that they can trace back, okay, to who are posting from which device at that time, okay. So this is the global address. Only one person or one device is using that IP address at a given time, okay. But there's also a concept of pool of IP address. Like for Gesesat University, we have many students, okay, and also faculties. So what they do is that when you log into the internet, okay, they will assign you an IP address. When you log out, you return the IP address, okay. So when another person sign in to the internet, they can assign that IP address to another person, but you can see that it will be at a different time, okay. So still at any given time, only one user is using it, okay. But they also the pool of IP address that they can share the resource, okay. They can use it at the same IP address at different time, okay, for different user. Okay, so this is important, the global IP address. In the reference, there will be like the website, okay, that you can search for the IP address. But I think if you want to pinpoint exactly, you have to pay. Okay, you can also search in the internet, okay, how to locate your the IP address, the location of the IP address, okay. The IP address has two parts, okay, the network identifier and host identifier. To identify the network and to identify the host, as the name said. There are many classes, okay, of the IPv4 address to make it flexible and to allow a mix of different network size, okay, on the internet. Because there are many network size, right? Sometimes network is small, sometimes network is big, and they want to communicate, okay, connect through the internet, all of them, okay. And usually there's only you use one class, okay, in a particular environment. So if you have the same company with many LAN, you will use the same class, okay. Now let's look at the class. There are the important class and class A, B, and C, okay, that we will talk about today. For class C is multi-class, class A we are not using, okay. The class A start with 0 here, class B start with 1 0, class C start with 1 1 0. So this is how you identify the class in the binary format, okay. In class A we have few networks, but each network we have many hosts. Gesesat right now, I just checked this morning, okay, they're using the class A IP address, okay. I think last year Gesesat used class B, okay, but right now they using class A. Anyway, so you have maximum of 126 network, okay, for class A, because the 0 and 127, this is reserved, okay, they are reserved, so we are not using, we're using 1 to 126 as the network, okay. Here this is 8 bits here, and this is 24 bits, so this is 3 bytes, okay. For class A has host of 3 bytes and a network of 1 byte or 8 bit. Okay. So 126 potential class A network, and the first dotted decimal would be 1 to 126. Dotted decimal would be like decimal dot, decimal dot, decimal dot, okay? These are all decimal number, okay? And so this is dotted decimal. For เกษตรศาสตร์ okay? Example is 110, actually this is decimal, 10 dot 17 dot 46 dot something, okay? So this is 10, okay? So this is a decimal number, so this is class A, okay? If it's in a binary representation, it would be 8 bits, right? But if it's in decimal, it would be 0 to 255, okay, for each of this number here. Okay, let's look at the format more. For class B, you have medium number of networks, and each has a medium number of hosts because you have 2 bytes for network, okay, and 2 bytes for host. Let's look at class C. Class C has 3 bytes for network and 1 byte for host. So class C is the smallest network, okay, in size, smallest size network, okay, has only few hosts, but this one is biggest size network, okay, for class A, okay. So class B begin with binary 10, okay, and in decimal number it start with 128 to 191, okay. All binary is this, okay. First 2 bits 10, okay. Second octet is also the part of the class B address, network address, okay. So you have 2 bytes for the network address, and you have this 2 to the 14 class B address, okay. You can check back to that picture in the previous slide, okay. And class C, you have many networks, okay, and small size network, okay, each with a few hosts. Start with 110, and in decimal is 192 to 223, okay. And the second and third part are also the network address, so only the fourth bytes, okay, are the host address, and there's total of this class C address, okay. So you can check here. This is 14 and 21 is the number of bits, okay, for the network address for class B and for class C. So that is the 2 to the 14, 2 to the 21 are the number of networks of class B and class C, okay, as I mentioned here, okay. Okay. Now for the subnet, okay. An organization may have many LANs, okay. Instead of having, the internet, okay, the rest of internet, okay, route to every small network, okay, by itself, okay, it's easier, okay, for the organization to do the routing inside, okay. So the rest of the network will see like big organization, for example, okay, and inside the organization they will just handle the routing, okay, by itself, okay. So for example, State University has Ethernet and also wireless LAN, okay. We have many LANs inside, okay. We have big organization, okay. To so simplify the routing, we assign a single network number, okay, which is 10.17. Okay. As I showed you before, this is the dotted decimal, class A, okay, to all the LAN, okay, inside the same organization. And then we use different subnet number, okay, for each LAN. So we use subnetwork, okay. This is like subnetwork inside of the big network of เกษตรศาสตร์ okay. So the host portion is partitioned into subnet number and host number. So we have first one is the network number, right, and this is the host number for class A, And then for this part, we divide it into two parts, okay? Into the subnet number and the host number. Okay, so this is the original host number of class A, but then we divide it into subnet and host number for the subnetworking, okay? The use of the address mask, okay, allow the host to route datagram to, whether the host is in the destination is in the same land or in another land, okay? We talked about the address mask here, okay? You can see that the mask, okay, and the subnetworking, okay, they come together, okay? So you have, okay, this is from Stalling also, book. Okay, this is examples of the IP address, okay? Binary representation, you have 8 bits, and then .8, okay? And the dotted decimal, you have 4 decimal numbers, okay, with a dot in between. So 1, and then this is 192. This one is 228, something like that. So this one is 17. This one is 57. Okay. Now the subnet mask, you know about the mask, right? That you put on your face, like for the COVID-19. So you mask is like you will let like your forehead, your eyes come through. People can see your eye, your forehead, but they cannot see your mouth and your nose, right? So mask is like you kind of close something, okay, so that cannot go through, okay, so people cannot see it, okay. So the mask in the binary format, okay, for the subnet, okay, is divided into two parts, okay, all 1 here and all 0, okay. So there are the part that you kind of cover something, and the part that you let people see it, okay. And you use the AND, okay, and operation, Boolean operation of AND, okay. So when you AND this and this, and then you get results here, whatever is 1 in the subnet mask, okay, you can go through, right? So this is the same as this. You can go through, okay, it's the same, okay. But whatever is 0 here, you cannot go through, you will get 0 here, okay. So this is covered, cannot see, because everything that and with the 0 will become 0, right? Okay, and this one go through. This one you can see the first part, okay. Now subnet mask in the dotted decimal will look like this. If it's all 1, 255, 255, 255, and the mask, okay, depend on how many bits for the mask. If it's 1, 1, 1, 3 bits, okay, and then all 0 is 224, you can, calculate by yourself, okay. Now when it's you bitwise and together, the part that you can go through is this, right? The first 3, okay, you can go through, and also the last part, okay, you can go through some part of it, okay. The first 3 bits of the fourth decimal of the fourth byte, okay, can go through. So 32 is like 001 and then all 0 here. So this is equal to 32, okay. So the first 3 bits only can go through the mask, okay. And from this, okay, you can see the subnet number. The subnet number, okay, from the one that you can see this, can go through, okay. The first 3 are the network number, right, for class C. This is class C. So first 3 bytes are the network number, class C network number, okay. So this is the subnet number, okay. in decimal is 1, in binary is 001. Okay, so this is a subnet number. Host number is the rest, okay, that you cannot see. Okay, this one that you cannot see. It's going down here. This so this is 25. Okay, I will show you in an example in a little bit, okay, to hope you can understand more. But basically, you have host here, and this is network number, right? And you divided the host into subnet number and host number, okay? And this is how you read the number in decimal and in binary. Okay, now this is class A default mask and example mask. For class A default mask is all 1 at the first, okay, because the first byte is a network number and the last 3 bytes are the host number, okay. So 255.0.0.0, this is default mask. Example of class A mask is you have more ones, okay. In the host part, you divide it into 2 parts. You have 2 bits for the subnet number and the rest is for the host number. So this one, when you calculate, is 192, okay. The number here depends on how many bits you giving as a 1, okay. For class B, you have default, okay, the first 2 bytes. Example is you have first 2 bytes and then you extend. This is the for the example of class B mask, okay. So you have 248, okay. If you have 5 bits as the subnet number mask, okay, mask for the subnet, okay. So you have 248. You just calculate 11111 and then 000, you get 248. So class C is the first 3 bytes, okay. Example is the first 3 bytes plus this is the network subnetwork part. So this is 6 bit, okay, for the subnet number. So 252, okay. So always you divide the host part into 2 parts, okay. And so okay, this is examples, okay, which hope you understand more. You have this is the rest of the network, right? You have router connect to LAN X, LAN Y, okay. LAN X, you have subnet number, okay, of this subnetwork, okay. So it's this one, basically this example here, 192.228.17.32, okay. And this is subnet number 1, okay. I can show you a little bit more. 32 is this, okay. So and you have the mask is up to here. It is a network subnet number, and okay, so it's 001, okay. So this corresponds to the table. For B, okay, for A is a device that connected to LAN X, okay. So it's in this subnetwork, okay. It's in this subnetwork 1, okay. So what is the host number? The subnet number equal to 1, okay, because it's connected to this LAN here. What is the host number? 33 means it's 0010001, okay. So this is the subnet number and this is the host number. So host number 1, okay. How about 57? 57 is actually these examples here, and so the host number is 25. Okay, I can write it again. 57 is 001 and then 11001, okay. So this is the subnet number and this is the host number. So when you calculate, only the host number is number 25, okay. But the total is, for including the subnet number and the host number, the total is 57, okay. Then you have LAN Y. LAN Y has the subnet number 2, okay. subnet number 2. So you can see that the first three dotted decimal, they are the same, right? Because it's class C, right? This is class C. So the first three dotted decimal, they are the same. This one is changed to 64. 64 is what? 64 is 0, 1, 0, 0, 0, 0, 0, 0. But the mask is up to here. Okay, so subnet number 2. Okay, 0, 1, 0 is subnet number 2. Okay, then this device is connected to LAN Y, and it has the IP address like this. So 65 is 0, 1, 0, 0, 0, 0, 0, 1. So subnet number 2 and host number 1. Okay, and then you have this router here connected to LAN C. LAN C has subnet ID, this one, 96. 96 is 0, 1, 1, 0, 0, 0, 0, 0. Okay, subnet number 3. Okay, and then this IP address 97 is 0, 1, 1, 0, 0, 0, 1. Okay, so subnet number 3 and host number 1. Okay, so this is subnet number 3 because it's connected to this router here. This one also subnet number 2 because it's connected to this router here. Okay, I hope you understand how the subnet is working. Okay, and so this is the reference. Thank you very much.